Hello students, today we will be going over 5.2, solving exponential equations. This is page 102 in your yellow packet. Okay, so page 102 in your yellow packet. Okay, our objective, I can solve exponential equations. Exponential equations are equations in which variables occur as exponents and are in the form a to the x equals a to the y. To solve exponential equations with the same base, use the property of equality of exponential functions. So I'll be using right here, property, exponential property of equality. If the bases are the same, then the exponents are equal. If you have 3 to the x equals 3 to the fourth power, we can remove the bases and just say x equals 4. Okay, so here's some equation and the properties and reason. Here you're given an equation. Then we use the distributive property, multiply 6, so it's 8 to the 6x plus 48, and this distribute the negative 4. Then, since they're the same bases, we can bring down the exponents. They have to be equal to each other. Then we add 4x to both sides, simplify here, and then using the addition property of equality. Then we subtract 48 using the subtraction property of equality. And then we divide by 10 on both sides and get x equals negative 2. Okay. Next, we're going to go ahead and go on to number 1. And I think you may have seen that in the answer key that I had up. So if you have the bases the same, we can say x plus 4 equals 12. And then we go subtract 4 from each side. And then we know that x equals 8. Okay. Next, we're going to go on to number 2. 7 is the base, and then you have these exponents. So if they're the same base, we know the exponents have to be equal. So negative 2 plus 6b equals negative 3 plus 6b. Okay, we want to get the variables on the same side. So we're going to go minus 6b minus 6b. Oh, there's no more variables, so negative 2 equals negative 3. Now, when the variables disappear, there's two different things that can happen. This can be a true statement or a false statement. In this case, negative 2 equals negative 3. That's a false statement. Now, when you get a false statement, your answer is empty set or no solution. Okay, if this had been true, then it would be infinitely many solutions. But in this case, it's false and there's no solution. Now we're going to go on to number 3. Okay, hopefully you can see all that. Okay, number 3 right here, we have 7 to the 3x plus 1 over 2x equals 7 to the negative 3x plus 3. Now, remember the division rule for exponents? We can subtract. So you get 3x plus 1 minus 2x. And again, I'm simplifying this part first before I go to this one. So I simplify that and I get x plus 1. So that would be my exponent. So I say 7 to the x plus 1 equals 7 to the negative 3x plus 3. Now again, they have the same basis, so I can set the exponents equal to each other. So I will say, I better do that maybe in a different color so you can see it just a little bit better because it's getting a little bit messy here. So if I put x plus 1 equals negative 3x plus 3. I move the x's to the same side. And I get, I'm going to erase that now, 4x plus 1 equals 3. And I'm going to go minus 1, 4x equals 2. And then I'm going to divide by 4. And that's probably getting pretty low there for you. Divide by 4 on each side. So x equals 2/4. And I'm going to simplify that to 1/2. So x equals 1/2. Okay. All right, we can go on to number 4. It's almost like the example 1. So we could say bases are the same, x equals -2. Easy peasy, that one. Didn't have to do much work there. Next, I'm going to go on to number 6, where we have these bases are the same. So I can say -5b plus b equals -4b. Next, I'm going to combine like terms here. -4b equals -4b. And I have to get them on the same side. So I'm going to go ahead and add 4b. I forgot the line down the equal sign. If I do that, I get 0 here and 0 there. And then there's no variable. So it's kind of like number 2. See number 2 up here? Right here. So there's no variable. So I look, are those numbers equal? See, this one was false, but guess what? This one's true. So if it's true, your answer is going to be infinitely many solutions or all real numbers. And that's a fancy R to say it's all real numbers. Okay? So you can write infinitely many solutions or all real numbers. So infinitely many solutions or all real numbers. Okay. So there you have it right there. All real numbers or infinitely many solutions or just the R right there. If you want, you can put just the R as long as you can make it fancy enough and not have it look just like a regular R. So that will mean all real numbers. Okay. Next, I'm going to go on to number 7. Okay.